Hello and welcome to chapters 1 and 2 here in the astronomy course for Thomas University. We're going to get started with this video lecture starting with chapter 1 on science and the universe, a brief tour. So we'll take a little tour of our universe. We start off with the very distant galaxies. Here are two galaxies that are interacting and colliding with each other. Now, it looks like they're actually hitting each other, but they're really not. The spacing between the individual stars is so great they don't really touch each other, but their gravity pulls them apart. Here we have the planet Mars, um, and that long streak you see across there is called Valles Marineris, or Mariner Valley, as first seen by the Mariner spacecraft in the 70s. This is like the Grand Canyon, but on a much larger scale. This valley is as long as the whole United States is wide. But here is the remnants of a supernova, a massive star that exploded back in the year 1054. And it was bright enough at the time to be seen during the daytime, and is the only supernova that we have seen in our own galaxy in recorded history. This is the Orion Nebula, which is one of my very favorites. I've done a lot of research on these little stars right here in the middle right here called the trapezium stars. There's four of them in there. And the Orion Nebula is about 1,400 light years away, so the light you see from that is 1,400 years old. Of course, we have the venerable Hubble Space Telescope, named after astronomer Edwin P. Hubble, which was born in Marshville, Missouri in late 1800s. Marshville, Missouri is just a few miles up the road on Interstate I-44 from me here in Springfield, Missouri. Hubble has been in space since 1990 and has been a remarkable telescope. And then our home base, the planet Earth. This is a disk image seen from geostationary orbit, 22,000 miles up. This is where we put weather satellites and communication satellites so they can be over the same spot all the time. Look closely enough, you can see a hurricane here off of Baja, California. So here's the Earth and the Moon drawn on a scale for both size and distance. This is not the scale, but this is our solar family of planets and dwarf planets. You'll notice that Pluto is no longer considered an actual planet, it's considered a dwarf planet, along with these others here, Hamana, Makemake, and Eris. We'll get into that in the course as to why it's a dwarf planet and not a real planet. Well, our Milky Way Galaxy is kind of like this, a spiral galaxy. Galaxies are billions of stars, maybe 200 to 300 billion stars. They look like hurricanes or whirlpools. And we do believe our own Milky Way Galaxy has a bar going through across it like this one does, along with these grand spiral arms of gas and dust making new stars. The Milky Way Galaxy can be seen from dark places on the Earth. And we see light and dark patches here, and the dark patches are actually dust in the Milky Way Galaxy. And so the two ingredients needed to make stars is gas and dust. Star clusters is they're generally very old clusters of stars. This one is called M9 out of the Messier catalog of galactic stuff we see in the sky. This one is about 25,000 light years away, so that light you see from the stars is 25,000 years old. We look at neighborhood galaxies. We have some nearby ones called the Large Magellanic and Small Magellanic Clouds. And this is a radio telescope array in the desert of northern Chile. The closest spiral galaxy to the Earth, to the Milky Way Galaxy, is the Andromeda Galaxy. In that Messier catalog, it's called M31. And it is probably about double the size of our own Milky Way Galaxy. You can see its spiral arms here in the dust, the dark stuff going around in the arms. And we do believe that the Andromeda Galaxy has two black holes in its center. We look at clusters of galaxies far, far away. This one is 60 million light years away. So you look at these galaxies, this is just shortly after the time the dinosaurs went extinct. You look at this. Very neat stuff. So, in the whole scheme of things, you look at a calendar, 365-day calendar of how the universe and solar system came to be. If you start on day one, the Big Bang occurs. It wasn't until October that Earth's atmosphere became oxygenated. It wasn't until Christmas of the year, December 25th, that dinosaurs appeared. On the 30th, the dinosaurs became extinct. And it wasn't until the last day of the year, on a grand scale of things, that the Big Bang occurred on January 1st, humans did not appear until the last day of the year. Here's another picture of the night sky from the desert in Chile, one of the greatest places on Earth to look at the night sky. And now we go into chapter 2. So this is the sky around us, and we can take a look at the horizon where the sky meets the ground. We can also make some definitions of some points in our sky. And so the point of an observer directly overhead you, straight up above, is called the zenith. Point directly above your head. Now, to make things easier, we construct models of things in science to make things easier and simplify difficult things to understand. And so in this figure we have what's called the celestial sphere, which is a simplified version of the night sky, where we place a sphere around the Earth, and everything in the night sky belongs on this sphere. And so the North Pole and South Pole of the Earth extend outwards to the celestial sphere, where the North Pole of the Earth comes out to the celestial sphere and hits the North Celestial Pole. Again, where you are on the Earth directly above you is called the zenith. And where the night sky hits the ground, that's your horizon. And here's a time-lapse photo of stars going around the South Celestial Pole. There really isn't a star at the South Celestial Pole like we have in the Northern Hemisphere, where we have the North Star named Polaris in the constellation of Ursa Minor, the small bear. You can see how everything rotates around the axis in the sky. So depending on what latitude you're at on the Earth, where if you're in Canada, Mexico, United States, North Pole, equator, you'll see things at very different places on the night sky. And throughout the year, as the Earth goes around the Sun, we see different constellations in the path of the Sun, and we call this the zodiac. And there's 13 of these constellations on the zodiac. And that has to do with astrology, which is totally different than astronomy. Astronomy is a science, astrology is not. So the tilt of the Earth is 23.5 degrees right now. It actually varies between 22 and 24 degrees over the course of many years. So we see our North Celestial Pole high in June and low in December. Here we have the rare constellation of Orion. I just got a new dog, named him Orion as my favorite constellation of Orion. And in Orion is a very neat constellation. You have a very red star here called Rigel, and a blue star named Betelgeuse. Excuse me, the red star up here is Betelgeuse, and the blue star up here down in his foot is called Rigel. So the blue star is very hot, red star is very cool. We have Orion's belt right here, and straight down from the middle of this belt is the sword, and within the sword right here is the Orion Nebula, which we've already seen that has trapezium stars in it, and that is a region of star formation with gas and dust. We know that the Earth is round because it casts a round shadow onto the moons in the heavens. We see that in a lunar eclipse when the moon passes through the shadow of the Earth. Oh, not too far. So the Earth casts a shadow out into space. We know that. Now, way back in ancient times, the philosopher Aristophanes measured the size of the Earth. He did this by measuring the angle at which the sun's rays hit our planet's surface at two different points, at Sen and Alexandria in ancient Mesopotamia, and he figure out what size the Earth was by the geometry of those two places. Precession is like a wobbling toy, a spinning axis. And so we go through this 26,000 year cycle where the North Star changes constantly. Right now the North Star is Polaris, but in 14,000 years it will be a bright star Vega. And we go through this precession over a 26,000 year cycle. Now, a planet like Mars can look as if it's going through a backwards motion as seen by the Earth. We call this retrograde motion. And it happens when the Earth overtakes Mars in orbit. So let's say Mars is ahead, Earth is behind, but Earth is a smaller orbit. Earth would come up and pass Mars, and then Mars appears to go backwards a little bit until we are in the transit. And backwards motion is called retrograde motion. Now, beginning early on, the philosopher Ptolemy thought that things were pretty complicated because of this retrograde motion. He would equate it to these things called deferents and epicycles. He basically said the planet would go around the Earth, and the Earth at the center. It's called geocentric Earth model. But the retrograde motion is seen by these epicycles, where the planet would go around in a circle, and at some point in time it would go backwards, apparently as seen by the Earth. Here the zodiac signs, pictures of the constellations, 12 of them, there's 13 of them. A big revolution came along, and when Nicholas Copernicus came along, Copernicus said Earth was not at the center of the universe, the Sun was. And we call it a heliocentric universe, not a geocentric universe. So Copernicus still had the Sun. He put the Sun in the middle of the universe, and around it. Now we also look at the faces of Venus. Venus kind of goes around the Sun, around the Earth inside of it orbit. And we do see some phases of Venus, like we see with the Moon. Galileo Galilei was the first to use a telescope, and one of the misconceptions is that Galileo invented the telescope. He did not invent it. It was invented by lens makers Hans Lieberschmidt in Italy. But Galileo was the first to use the lens as a telescope. Here's his telescope. It was a wooden tube covered with paper and a lens 26 millimeters across, about an inch. And that's the end of week 1 lecture. Thank you for joining me.